Hello all, we are a team of dedicated aptitude trainers and we are currently working on a new project called online TSA.in blog, and today's target is to learn alligation, which comes as part of arithmetic section across various global competitive exams as far as aptitude is concerned. And let's start with the very first question, which is, what is the fundamental thing about alligation? And the best thing to note is there is no separate concept like alligation. If it is not a separate concept, what is it like? Alligation is nothing but a different representation of weighted average. Now, to understand alligation, we have introduced weighted average. Let us see how we can learn weighted average and go towards alligation. The first thing to recall is simple average, which is nothing but sum of all our observations divided by the total number of observations. If the observations are 10, 20, 30 and 40, then simple average is given by 10 plus 20 plus 30 plus 40 divided by the total number of observations, which is 4 here, and that gives us a final value of 25. So 25 is the average of 10, 20, 30 and 40. Now let us consider a question. Average marks of a class A is given as 90, whereas that of class B is given as 80. Can we say that the total average when we consider both the classes is 90 plus 80 divided by 2, which is 170 by 2 or 85? Can we say that the cumulative average is 85? To answer this question, let us consider two scenarios. Scenario first says class A has 50 students and class B 100. The total marks for class A will be given by 50 multiplied by 90. 50, as I already said, is the strength of class A, and 90 is nothing but the average marks of class A. That gives us the total marks for class A as 4500. Now the total marks for class B similarly will be 100 multiplied by 80, that is 8000. Average will be given by total marks divided by total number of students. Total marks is 4500 plus 8000, and total number of students will be equal to 50 plus 100. That gives us a value of 83.33 for the first scenario. Let us take out the second scenario where we have assumed the class A and B to be having 180 students respectively. The total marks for class A will be 100 multiplied by 90, which is 9000, and the total marks for class B 80 multiplied by 80, that is 6400. Now the total average becomes 9000 plus 6400 divided by total number of students, which is 180 here, and we get a value of 85.55 in the second scenario. Now we see that the two scenarios differed only in the number of students that class A and B had, and we had two different values as 83.33 and 85.55. Looks like we need the weights of the individual classes to find out the correct average, which is true. But there is another aspect. If the weights are not given in the form of absolute values but ratio, even then we should be able to calculate the cumulative average. Let us see how. Let us do a repeat of the first scenario where we had assumed 50 and 100 as the number of students of class A and B. Rather than taking the absolute values 50 and 100, we take 1:2 as the ratio. And now we should see that average will be 90 multiplied by 1 plus 80 multiplied by 2. 1 and 2 are the weights here. Divided by total weights, which is equal to 1 plus 2 and 3. And this gives us a value 83.33. And below you can see the previous calculation we did in scenario 1, which also gives us 83.33. That shows us that even if we don't work out with absolute values and we have just ratio given in the question, we should be able to calculate the average. There is a second observation which we would like to tell, and that is two averages which were given to us for class A and B were 90 and 80. The midpoint of 90 and 80 is nothing but 85. Now consider the first scenario when the weights were 50 and 100. Cumulative average was noted out to be 83.33. Now you see that midpoint value is 85 and the cumulative average for the first scenario was 83.33, which is less than 85. And this is logical. Why? Because the weight of class B, the number of students of class B, is more than the number of students of class A. And that's why the cumulative average drags from 85 to a value which is lesser than 85, and that is 83.33. Similarly, when the second scenario said that there were 100 and 80 as the number of students in class A and B respectively, the cumulative average came out to be 85.56, which is more than 85. So we already know the midpoint was 85, but then the strength of class A is more than the strength of class B, and that's why the cumulative average gets dragged from 85 towards 90, and we see that it is 85.56 precisely, which is more than the midpoint value. And this is again a logical thing. Let's quickly attempt a question based upon the last concept that we read, based upon the midpoint of the averages. In an examination hall, the ratio of boys and girls is given as 3:4. If the average age of boys is 18 years and that of girls is 16 years, what is the average age of the entire hall? And we have 4 options given here. So the ratio is 3:4 and the average ages are given as 18 and 16. Now we know that the total average age will be total age divided by total number of people in the examination hall. Now the total age is 18 multiplied by 3 and 16 multiplied by 4, which gives us 118 as the total age. The total examinees, students, is equal to 3 plus 4, which is nothing but 7. Please note that 7 is not the number of people who are taking the exam, but then 3 and 4 have been given as the weight, or you can say the ratio of boys and girls. And that gives us a value of 16.86. Now, you notice that 18 and 16 were the averages given, so the midpoint value was 17. And now, the girls were more in number compared to the boys, and that's why the cumulative average would be lesser than 17. Only one option, which is B, satisfied that. Let us now try another question. 50% milk solution is mixed with 80% milk solution to result in a 60% milk solution. The question is, what is the ratio of both the milk solutions? We already learned the principle of weighted average. Consider the weight of the two milk solutions be Y and Z. The ratio will be Y is to Z, and the average weight will be given by 50% multiplied by Y plus 80% multiplied by Z divided by the total weight, which is Y plus Z here, and that has been given as 60. We can cancel out percentage and zeros here to let the equation become 5Y plus 8Z is equal to 6Y plus 6Z. Let us transpose 5Y to the right hand side and 6Z to the left hand side. We should be able to get Y is to Z as 2 is to 1. And this is what we had assumed. Y and Z are the ratio of the weights of the two solutions. Thus, 50% milk solution needs to be mixed with 80% milk solution in the ratio 2 is to 1. However, there is another method to write the percentages in one line and the resultant percentage in the second line. So 50% and 80% were the two percentages that we wrote in the first line here, and 60% is the resultant percentage. The next thing is to subtract 60% from 80% and write the value here. 80 minus 60 is 20, we write 20 here, and 60 minus 50 is 10, we write here. So the results are written on the opposite diagonal. Once we have written 20 and 10, we should notice that the 50% milk solution needs to be mixed with 80% mixed solution in the ratio 20 is to 10, which is nothing but 2 is to 1. And this is the same answer that we got when we used the formula for weighted average. Interestingly, this second method is known as alligation, which is nothing but another representation of weighted average, and that has simplified our calculation. It does not include any variables as such and gives us the result, the ratio that we seek from the answer. Now, let us try to understand how alligation pictorial representation is same as the weighted average. Let us consider the average weight of class A as A and average weight of class B as small b. If the ratio of students in class A and B is given as m is to n, then the weighted average will be total weight divided by total number of students. M into A will be the total weight of class A, and N into B will be the total weight of class B. Total number of observation or total sum of weight is given as M plus N. W, the weighted average, will be given as MA plus NB divided by M plus N. When we cross multiply, we should get MW plus NW is equal to MA plus NB. And upon rearranging, we should be seeing M is to N is nothing but B minus W is to W minus A. This is same as what we already saw when we mixed the milk solution of 50% and 80%. Here we write the mixing solutions to be A and B and the resultant solution to be W. We minus W from B and write it here, B minus W, and we minus A from W and write it here, which is W minus A. This gives us the ratio M is to N.
B minus W divided by W minus A. Now that we know alligation and weighted average have nothing but the size of the two coins, of the same coin precisely, when do I use alligation and when do I use weighted average? There's a very simple and golden rule, and that is when all the averages are given, when all the average weights are given, we use alligation. If the weights given are 50, 80 and the resultant average is 60, we can use alligation to find out in which ratio 50% and 80% milk solution are being mixed. Similarly, if the weighted average is to be used, the scenario should be contributing averages are given, but then we need to be calculating the cumulative average or the weighted average, and then we will use the formula for weighted average. Hope you understand when we can use alligation and then we can use weighted average. Thanks for watching this video.